Assalamu alaikum everyone. Today we are going to talk about types and characteristics of Earth's orbits. So now let's get started. Now talking about the very first orbit, which is low Earth orbit, also known as LEO. It is, as its name suggests, it is an orbit that is very relatively closest to Earth's surface. Now coming to its characteristics, first of all we have altitude. Any satellite in LEO will have an altitude of about less than 2000 kilometers, but also it can be as low as 160 kilometers. Now, coming to its orbital speed, we can say any satellite orbiting in LEO will have an orbital speed of about 7.8 kilometers per second. Now, any satellite orbiting in about at this speed in LEO will have an orbital period of about 90 to 120 minutes, which means that any satellite orbiting in LEO will take about 90 to 120 minutes to complete its one rotation around Earth. A very common example that we have of LEO is of International Space Station ISS. Now it is orbiting in LEO and it takes about 16 rotations a day. Now, a very common characteristic that we have of LEO is that LEO satellites do not always have to follow a particular path around Earth, which means that their planes can be tilted. Now, this means that there are more available routes for satellite, and due to this very unique feature, we can say that LEO is a very commonly used orbit. Now, talking about its uses, we can say that it is an orbit most commonly used for satellite imaging, as you know that it is at lowest altitude, and due to this very reason astronauts can take images of very high resolution and very vivid images. And it is also used in military purposes, as you can fly by the same area multiple times each day.
Now coming to medium Earth orbits. The medium Earth orbits comprises a wide range of orbits anywhere between low Earth orbit and geostationary Earth orbits. It is similar to LEO in a sense that it doesn't need any specific paths around Earth, and it is used by a variety of satellites with different applications. It extends from 2000 to right below 35,786 kilometers, and the most common altitude is approximately 20,200 kilometers, which yields an orbital period of 12 hours as used by the Global Positioning System. So these satellites are used in communication and navigation purposes, that is, from tracking large jumbo jets to actually getting directions to your smartphone. One limitation is that in these orbits there are Van Allen radiation belts, and these belts can hurt the performance of satellites due to highly charged particles maintained by the Earth's magnetic field. Now coming to geostationary orbits. The satellites in geostationary orbits circle Earth above the equator from west to east, following Earth's rotation. It has altitude of nearly 36,000 kilometers, and in order to perfectly match Earth's rotation, the speed of geosatellites should be about 3 kilometers per second. It takes 23 hours 56 minutes and 4 seconds to complete one revolution exactly the same rate as Earth. Well, this makes the satellites in GEO appear to be stationary with respect to Earth. GEO is used by satellites that need to stay constantly above one particular place over Earth, such as telecommunication satellites. This way, an antenna on Earth can be fixed to always stay pointed towards that satellite without moving. It can also be used by weather monitoring satellites because they can continually observe specific areas to see how weather trends emerge there. Now the main limitation of this orbit is that the satellites can only be placed at the equator, and the cost of launching these satellites at such altitudes is much high.
High Earth orbit. It is an orbit beyond geostationary orbit to have altitude greater than 35,786 km. Not to be confused with highly elliptical orbit. It has orbital period greater than 24 hours. And since Earth's rotation speed is greater, so satellites in high Earth orbit appear to be having retrograde orbits, means moving backwards. Useful to study Earth's magnetosphere and astronomical observations. It faces very less atmospheric drag interference. Some drawbacks are: first one is that cost of manufacturing and launching satellites in high Earth orbit is very high, and second is communication.
Thanks for watching.